Chris, are you with me?
Yes, sir.
Okay. Now I'll keep asking you guys. Okay. I certainly need feedback from you guys, right? When I'm teaching, you have to tell me whether I'm teaching it right or not. Am I making it simple or am I complicating things? Here, no complaints. Okay. All right. Let's go to the next one. This is a tricky one. Okay. So this one would need more attention. This was the first theorem to be proved for for no, I mean first circle theorem to be proved, and I purposely did not try explaining that yesterday because that would have been a ride for anybody who is seeing it for the first time. And I was also struggling with myself to see how I can explain that in a simpler way. What this theorem says, I mean, this is the last theorem, okay? It says alternate segment theorem, okay? Meaning, if I have 3 points on the perimeter and I join them, okay? Now, if I draw a tangent on any of the point on the chord, let's say this is the tangent, this is making some angle here. Let's call it A. This one says if you have 3 points on the perimeter, then this angle made with the tangent, okay, is equal to this angle. And remember, these two lines are not parallel, okay? They don't have to be parallel. In any circumstance, if you have 3 points on the perimeter and you draw a tangent from one of the angle, okay, if I don't draw it here, if I choose to draw a tangent here, and then this angle will be equal to this angle. That's what it says. Similarly, if I chose to draw a tangent on this point, then this angle made by this chord is going to be equal to this angle. That's what this one says. Meaning, any tangent, the angle made by the tangent against that chord adjacent to it, this angle is same as the angle that you see in the far opposite corner. Okay, not here, this one. So this somewhat resembles with the alternate angle, right? That you would have seen with the parallel lines. This angle and this angle are same. So here, if you see, this looks like the alternate angle. I mean, if you compare it with the parallel lines. Okay. So now let's see how do we prove this. Any guesses? Anybody can take a punt at it and tell me if you guys can give me a direction for proving this. This is my circle. We have taken, let's say, 3 points. So there are 3 chords here, A, B and C. Okay. Let's choose this point. Here I am drawing a tangent. Tangent meaning this is my center. My tangent is always 90 degree against the center, okay? Not with this line or this line or any other line. So when you talk about drawing a tangent on any point on the perimeter of a circle, we are essentially talking about joining that point with the center and making 90 degree angle. This is the line which is tangent. So here, let me not confuse you guys. This is my angle, and we are trying to prove that angle, let's say CAB is equal to, let's say this is, let's pick a point here, D, is equal to angle DCB. This is what is to be proved. Okay, and now I'm saying this is my center. So let me put a dotted line here, and this dotted line is making 90 degree. Now, again, stress out your brain and tell me if you can guide me how I can prove this. And see if you can think little creatively here. this angle. See, this will look a little complicated, okay? I just want you guys to pay attention here. First thing is, let's join this one with the other, this one, okay? Other end of the card. Let's say this was my tangent here. We have to find out what is the value of this angle and how this angle is equal to this one. Meaning, we have to prove this one, right? Now, what did I do? I have just joined this. Okay, anybody wants to take an attempt or tell me at least the approach part of it? Ritika, Hir, Dhanushri, anybody? Ishwari? No? Sunarka? Arya? Anybody? Yep, yeah, Ishwari.
Is it because ABC is an isosceles triangle, so then angle CAB and angle ACB are congruent, and so
ACB is isosceles triangle. No, I don't think we have any evidence or any proof for that. I randomly chose 3 points. Let's say if I have a circle like this, if I pick 3 points like this, by no means this will be an isosceles triangle. Okay, there's no. I mean, it could be, it may not be, depending on how I'm choosing the points. The theorem is generic in nature, so we cannot go with the assumption that this is isosceles triangle. It could be, it could not be, it may not be. Okay. So okay, but that was a good attempt, Ishwari. Okay, I mean, I want you guys to make attempts. Anybody else? Ritika, Ananya, Arya, anybody? Give me some clue. Give me some guidance. Your teacher needs guidance. Pranit.
Sir,
Yeah.
for proving this, we need the same length of hypotenuse on this side. The same length of hypotenuse on this side. We need RHS.
You need RHS. Maybe, may not be. But no, but if you, when you say RHS, I mean, can you tell me what? See again, when you say RHS, you are essentially talking about 2 triangles being congruent, right? So what are those 2 triangles that you have in your mind? No, I mean, again, I am not putting anybody on the spot. I am just making you guys think. More you think, more equipped you will be. Yep. Yeah, Pranit. Okay. Ritika, here, anybody?
So do you want us to work it out, or do you
No,
want us
I want you
do
to explain at least the approach. How would you approach in this situation? When you have to prove this theorem, what would be your approach? Because that is important.
I'm not sure, sir.
Okay. Let's see. Pranit also is trying to say something. Yeah.
So in this, you have already one-sided, already like one side between both the angles. There's a side there, and then you already showed us one of the theorems where if two tangents meet at a point, they're equal inside.
But we don't have 2 tangents here.
If you draw a tangent between on B,
Okay.
that would mean D, meaning CD and BD are equal,
Okay.
and CB are also equal, making that 1, and then so that would be
Then this and this are equal. That means these are isosceles triangle. This angle and this angle will be same. But our goal is to prove this angle equal to this angle. We have still proved the outside one. Yeah. So see again, this is how you brainstorm. Okay. I will teach something today. I will forget. I'll be honest with you guys. Okay. Before I came to the class, I went through these theorems one more time. I drew it on a piece of paper to see how I can prove it. Because if I come to the class being confused, I'll waste everybody's time. Correct? So I did that homework because I had proved this 35 years ago. Right, not 35. Yeah, close to 30 years ago at least. Yeah. So now, okay, let me give you guys some clue here. Again, as I said, the most important theorem with respect to circle is this one. If you have a chord, the angle that it makes on the perimeter is half of the angle it makes on the center. And that's the reason why I joined this. Now, what do we see from this? If you look at angle COB, this one, if you look at, I'm looking at this chord, okay, CB. The angle made from the center is angle COB, which is 2 times the angle that it makes here, okay, that is CAB. Yeah, agree? This chord is making this angle on the center and this angle here. Yeah. So this angle is 2 times this angle. This part is okay. Now this angle is 2 times this angle. Now look at this angle plus this angle and this tiny angle are together making 180 degree. Correct? Okay, so that got dropped off. I think I confused him enough. Alright, so if I'm looking at triangle, now look at triangle, and again you guys will need to pay attention, okay? Make sure that you're not missing any of my golden words. So if you look at triangle COB, yeah, COB, I'm looking at this thin triangle that you see on the center. Here, the angle COB plus the angle OCB plus this angle OBC, this equals 180 degree. Yeah, that means this angle and this angle, if I look at this angle OCB will be equal to what? OCB. Now, okay, before I go there, now this angle OCB and angle OBC, they are same. Agree or you don't?
Agree.
Why?
Because it's a nice isosceles.
It's nice, yeah.
The radius are equal to each other, making it an isosceles.
Exactly. That's a good catch. So this angle and this angle are same because these are the two radius, both are same. That means in an isosceles triangle, so these two angles have to be same. So I can change this equation and say angle COB, angle COB plus OCB and OBC both are same. This angle and this angle are same. So I can say 2 times of angle OCB equals 180 degree. Yeah. And angle OCB, or I'm just going ahead with my storytelling. And 2 times angle OCB equals 180 degree minus angle COB. Yeah. Now COB, which is what? COB, this angle is 2 times of this angle, correct? I can put that value here and say, okay, 180 degree minus 2 times of CAB, angle CAB. Yeah. So here, angle OCB in this equation, the angle 2 times angle OCB is this much. So I'm just going to divide everything by 2. So angle OCB becomes 90 degree minus 2 times, not 2 times, 2 gets knocked off, angle CAB. So let me write a cleaner version of the equation so that you guys don't get confused. So what did I do? I have these 3 points in the perimeter, I just joined them. And I picked 1 point from where I have drawn the tangent. And this is the angle that it makes against this chord. We have to prove this angle is equal to this angle. Yeah. First thing I did was I picked up the center of the circle. I joined up with the dotted line so that I have one triangle here, OCB. And when I looked at this triangle, there was a reason. This angle OCB is 2 times this angle, right? This part we saw here. This we know from the first theorem. So this angle is half of this angle. Now, taking that information and coming back to this triangle again. In this, any triangle for that matter, sum of all the 3 angles is 180 degree. That's what we saw here. And since this angle and this angle are same, because this triangle is an isosceles triangle, OCB, that you see in the center. It's an isosceles triangle, so this side is equal to this side because both are radius. So this angle is equal to this angle. So I'm putting sum of the 3 angles, this angle plus this angle plus this angle is equal to 180 degree. And since this and this are same, so I'm saying angle COB, meaning the angle on the center, plus 2 times of one of the angles. So I pick this angle. Angle COB plus 2 times of this angle will be equal to 180 degree. That's the equation. Everybody with me, right? So far I'm not forcing you guys to get confused, correct? Okay. Somebody said thumbs up, meaning I am doing so. No? Okay. Alright. So now this is my simple understanding of the triangle. That okay, sum of 3 angles is 180 degrees. So angle on the center COB plus 2 times of this angle is equal to 180 degree. Now I'm going with my calculation. So okay, I'm putting OCB, this angle, only this angle, okay. 2 times of this angle equals 180 minus the center angle on the center. Now whatever we saw here, we are putting the value here because ultimately our goal is to get relationship between this angle and this angle, right? We have to come to that. So we use this finding and use in this triangles angles to tweak my equation. Okay. Now from this what we got was angle OCB, meaning this angle is equals to 90 degree minus this angle. Yeah. 90 degree minus angle CAB, meaning OCB, this angle is 90 degree minus this angle. Now you look at this, now you look at this angle, 90 degree minus this angle. Now look at this part. Now look at this tangent, OC tangent on line CD. OC is tangent on line CD, okay? This is perpendicular on this one. Now this whole angle is made of what? This angle plus this angle, correct? Or let me not go there. Let's look at it this way. So angle OCB plus this angle. From here it comes this side, so it becomes plus. Angle CAB equals 90 degree. So far it's fine, right? I'm just juggling with the same equation, right? I moved from this side to that side. Now it says this angle plus this angle is 90 degree. Now you look at this picture alone. This angle plus this angle is also 90 degree. Right? By looking at just this, I don't know if I am giving you guys a clue or I am making you guys worry, but I will clear the rest if there is any. Okay. Now, if I am looking at only this part, what do I see? Angle this one plus this one makes 90 degree. This is my tangent. Yeah. So angle OCB plus this angle BCD equals 90 degree. Okay. Now, if you look at these two equations, what do you see? This and this are common in both of them. This and this are common in both of them. That means this angle is equals to this angle, meaning angle BCD equals angle CAB. Now BCD, this is this angle, is equals CAB. This is what we were trying to prove. and I'm a very proud teacher saying that we proved it. But don't worry about it. We'll go back to the drawing board again and relook at the whole journey. What did we do? So whatever I have done, be it drama or circus, was it understandable to you guys so far? I'm anyways going to do a recap, but still I'm just checking. Yeah?
Yes.
Okay. Now let's look at the whole journey from beginning to end. We had a circle, we picked up 3 points and joined them. So basically we have 3 cards here. A, B, C. So, and if I choose this point and draw a tangent, when I draw a tangent, what do? I join it with the center and make a 90-degree angle. If I'm drawing a tangent here, what this says is the angle this tangent makes with this chord is equal to the alternate internal angle, meaning this angle is equal to this angle. First thing what we did was we said, okay, fine, my first theorem is my best theorem, meaning if this I'm taking this chord, this angle is 2 times of this angle. So we found a relationship between this angle and this angle. That we did. After that, we say, okay, fine. Now, if I have this triangle alone, OBC, in this triangle, what we see is sum of all the 3 angles is 180 degree, and this guy is 2 times of this guy. So we put and since this triangle is an isosceles triangle, this angle is equal to this angle. So 2 times of this angle plus this angle equal to 180 degree, and this angle is equal to 2 times of this one. So we substituted that value. From that we found that this angle is 90 degree minus this angle. That's what it became. And then we saw that, okay, here if I am looking at this 90 degree, this angle plus this angle is 90 degree. So we found the common things, and that gave me a thing that this angle's value is equal to this angle. Yeah. If it sounded a little cryptic, it's obvious, it's normal, and that is where you guys can give me one extra view by watching this video. Again, I'm not very keen on getting views and all those stuff, but on a serious note, when you watch this video after the class, I mean, I'm sure you would not remember each one of them what we have proved so far, but after the class, whenever you get confused, just watch this part of the video and look at the step-by-step thing. When I'm doing it, draw a circle. Okay, you also draw a circle. Pause the video. Then what did I do? I had picked 3 points and drawn this triangle, the 3 cards. Then I had drawn a tangent. My simple thing is, a tangent is nothing but it's a 90 degree that makes with the center. Make that triangle, and then join these points and make that as a triangle. Get this angle and this angle's relationship from the first theorem, and then sum of these 3 angles is 180 degree. Put that in the equation and do it one by one. You'll be able to solve it. It's not a difficult one, but you will feel more confident when you kind of do it on a piece of paper, okay, by yourself. Okay, now time for bothering you guys. Let's see if Aryan, you guys understood?
Yeah, I understood it, but
Okay.
I might need to watch the video.
That's the purpose for this video, in fact, right? I mean, I'm not a famous personality. I just make videos for you guys. Okay. How about Chris?
Yeah, I would say that I understood like the 6 other, like the.
This one is little.
theorems, but I think this one was kind of confusing, so I'll probably watch the video again.
And watching the video will certainly make you guys a little more comfortable, but then my recommendation would be get your hands dirty. Okay, by just don't trust me. I mean, just keep doing it by yourself. So just watch the video, pause it. Okay, I have drawn a circle. You also draw a circle. Go to the next step. Go to the next step. Like what I'm doing. Okay, and don't let it go till you're confident by doing it yourself. Okay. Alright, so here Ritika, Shravya, Dhanushree, everybody understood, confused, an opportunity to watch this video?
Understood.
Understood. Okay. Okay. So basically, if you look at this one, right? What is the time right now? Oh, it's already 4 o'clock. So today we did nothing different from what we started yesterday, but these are circle theorems, and unfortunately the problem is I don't believe in just telling anybody a theorem and saying that okay, memorize it, because that's not the way math is supposed to be learned. So sometimes you will find me going a little slow, but the main objective is that I'm here to give you guys a concept, not a theory or a formula and then ask you to mug it up. Okay, so that is one thing which might take a little time at times, but then you can be rest assured that you would have a very clear view of how you would want to solve problems by knowing the concept rather than memorizing the formulas. Okay, that brings us to the end of the class. I would not say that if there is no confusion. I'm sure there will be confusion, and that is what will require you guys to just go through this video, do it yourself. Then you'll be able to relate. I mean, these are not difficult concepts, but practice is what would be needed to make it more comforting. Yeah. All right. Thank you guys. You can enjoy the rest of your evening.